In this video, we'll discuss about some of the algorithms for tasks, machine learning tasks like classification, regression, and clustering. There are many algorithms, and the algorithms which are very popular one we will be discussing. There are more than these many algorithms, but not all the algorithms have been mentioned in this video. I have just chosen some of the popular one. So in the classification algorithms, logistic regression, naive Bayes classifier, k-nearest neighbor, which is also called KNN, support vector machine, decision tree classifier. For regression algorithms, we will go through linear regression, naive Bayes regressor, k-nearest neighbor, support vector machine, decision tree regressor. You can see that some of the algorithms are common for classification and regression, say naive Bayes, KNN, SVM, decision tree. Clustering algorithms, K means clustering, agglomerative clustering. Supervised machine learning algorithms are used for classification and regression. Unsupervised machine learning algorithms meant for clustering tasks. So supervised logistic regression. This is a statistical method where there are one or more independent variables and we determine an outcome. The outcome is measured where there are only two possible here outcomes, predicting a binary one, 0, 1, true or false. The function h theta of x is equal to a function g which takes into input parameter, and the inputs are x1 and x2. The g is any one of the function which can be, here it is means sigmoid function. In this diagram there are three plots which we are able to see. The two classes, one is blue color circle and is red color cross. We're trying to fit a function. In the leftmost, if we see, the function which is tried to fit in this data is not giving a very accurate result. This is called underfitting. The second one is adequate and is also a good fitting, where only two of the crosses are misclassified, otherwise the maximum number of data points have been classified correctly. The third one is called overfitting. The function is trying to overfit the data points, and the function which has generated is a very complex one, which is a higher degree polynomial. So which one is the best? The middle one is the best, because both underfitting and overfitting is not it is not good for the accurate outcomes. The logistic regression is also known as used for a good baseline, where you can measure the performance or other complex algorithms. It is very efficient and highly interpretable. The negative part is it is not one of the most powerful algorithms, and it has high reliance on a proper presentation of our data. The outcome is discrete and can predict only a categorical outcome, not a numerical one, and it has vulnerability to overfitting. Linear regression is a supervised, where we predict the scores of one variable from the scores of a second variable. So there is two variables, x and y. X is the predictor variable and y is the criterion variable. Linear regression, it tries to find the best fitting straight line through the points. So these are the data points, and the line is trying to fit the points. The distance between the points in the line and the actual data points give the error term E. The objective is to minimize the error term. If all the data points lie in the same line, then the error term will become 0. Naive Bayes, it's a set of supervised learning algorithm which is applying Bayes theorem. The word naive means the conditional independence between every pair of features given the value of the class variable. So total number of input features, if it is 3, the conditional dependence between these features are assumed that there is no such dependence. They are independent of each other. This is the formula for the Bayes theorem, where we can compute the posterior probability taking the input as likelihood, class prior probability and the predictor prior probability. This naive Bayes algorithm is used where there is an uncertainty in the environment and it is based on the probabilistic decision making. Simple example here is a data set with 2 labels, green and the yellow. First, calculate the probability of these classes by having probability of yellow 7 divided by the total, that is 17. Probability of the green circle is equal to 10 greens divided by total 70. So coming to the prior probabilities, number of samples in a given class divided by the total number of samples. So similar to that, P of yellow, P of green we have already computed, and then we can have a conditional probability which is P prime, and we want to know what is the color of this question mark circle. So to know the question mark circle, we first compute this conditional probability of question mark given green. So in this particular circle there are 3 greens, considering the question mark as a separate one. So we write here 3 out of total 10, and then out of P prime question mark by yellow, that is 1 by 7. Then computing the posterior probability by using this Bayes theorem, we compute and then we come to know whichever probability is high, the question mark, the value will be green or yellow. So presently, by having higher probability that the question mark is in green in color. This is how the naive Bayes calculation is done. Coming to another supervised decision tree algorithm which is very popular. The decision tree, this is outcome variables can be predicted, which can be a categorical or a numerical. If it is categorical, it is used for classification. If it is numerical, then it is used for the regression. Here in this example, there is a in this decision tree, the split is done at the root level, and every node represents the feature on which the split is being done. So gender, if it is female or male. Similarly, if the root is a class, then there are 2 classes, class 9 and class 10. And then again we compute the how many students play cricket out of female, how many students play cricket of male, students who play cricket in class 9 and students who play cricket in the class 10. How decision tree is used in classification? The decision trees, if we are using for classification, then the response variable has only 2 categories and it can also have multiple categories. So depending on 2 categories or multiple categories, the variant of the decision tree is used. For regression, the response variable is continuous, and then there are 2 such cases where linear relationship exists between predictors and response, and another condition is non-linear relation between predictors and response. Depending on these conditions, either we use the standard regression tree or C4.5 variant of the decision tree. Coming to the k nearest neighbor, this is also a simple algorithm which stores all the cases and classifies new cases based on the distance function, which is used for similarity measure. So class is classified by a majority vote of its neighbors, with the case being assigned to the class most common among its 8 nearest neighbors, measured by the distance function. So if k is equal to 1, that is only nearest neighbor, then simply we assign the same class that of the nearest neighbor. So here these are the two classes, class A and class B. And now if we have taken k equal to 1 and we need to assign the class to the question mark, then we take one of them, k equal to 1. So it is just the red star class A. So the question mark is assigned. If we make it k equal to 3 and then make the circle, then we do a voting that how many of them are class A, how many of class B, and the class which is having more number will be assigned to the question mark. Then support vector machine, SVM, popularly called SVM, is a supervised machine learning algorithm used for both classification and regression. Here the classification is about finding the hyperplane that differentiates between the two classes very well. So the terminology used in support vector machine, separating an hyperplane, it's having a support vector green and then support vector red, support vector for the blue, separating the blue points, and support vector for separating the red points. So it's basically drawing a hyperplane with margins on both of these sides to segregate blue points and the red points. Clustering is a machine learning technique, involves in grouping of the data points, and where the data points are the same group which having the similar properties or features, and the data in the different groups have high dissimilar properties. K means clustering and hierarchical clustering, the two types of clustering methods. In this K means clustering, a centroid is computed randomly and then each point is assigned with the distance function, and a new centroid is again computed iteratively till the centroid position becomes fixed or standardized. So this can be seen, this is a hierarchical cluster, also called a dendrogram. Hierarchical clustering using the tree structure, agglomerative and the dendrogram. So here depending on the distance measure, the 2 points are joined, A and E are joined, B and C are joined, and then these 2 points are joined to form D. K means clustering. Initially we have to assign the K number of clusters. So the value of K is a prerequisite, and it often terminates at the local maxima. K has to be known beforehand. There is a method called elbow method which helps to know the value of K. The disadvantage is that the K means cannot handle noisy data and outliers. How good is the model? The performance evaluation of the model. For classification models, the metrics are confusion metrics, precision, recall, accuracy, F1 score, area under the curve. Performance metrics for regression models are mean square error, root mean squared error, mean absolute error, R-square, or coefficient of determination, and adjusted R-square. These same functions when we use with the scikit-learn libraries for classification logistic regression. The package used is logistic regression. The function is used is logistic regression, coming under the package sklearn.linear model. Similarly, for naive Bayes, it is sklearn.naive Bayes import Gaussian NP. Decision tree sklearn.tree import decision tree classifier, and support vector machine sklearn.svm import SVC. Similarly, for regression, the packages are sklearn.linear model, sklearn.naivebase, sklearn.neighbors, sklearn. So far we have seen through the various concepts of all the machine learning algorithms for classification, regression and the clustering. The data is the main input. So depending on the data, the algorithms work, and various categories of data. After learning, the task of prediction is done, either classification or regression. Or for these jobs, there are multiple algorithms, and the best way is to compare the algorithms and do the performance measure. Some of the references which you can try. Thank you.